The derivatives of inverse functions and inverse trig functions. So the first thing I want to do is just draw a quick picture, and I know that this is wrong, but what that looks like, and the point 1, 2, 2. So we can find the slope right there. Only if you're crazy definition of the derivative. You would only use it if I told you to use it, hopefully. So the slope when x is 1 is 7, quite steeply. There's that. Okay. So what I'm going to do, or what the first part of this lesson is about, is how this picture to actually do the derivative of the inverse without doing a pile of work. But I'm not going to tell you that yet. But that's what today's lesson. The derivative without doing all of this. So the inverse is a graph that looks like this. 2, 1, it goes through the point. Or sorry, 1, 2, it goes through the point. If I could draw. I really suck. I'll draw it properly. This. Whatever. It is terrible. Is this slope? That's what today's lesson is about, is how can I get the slope of that point without actually doing a pile of work. So A, you can all answer without doing any work. Mr. App, since the point 1, 2 is on the graph, why does it follow that 2, 1 is on the graph of the inverse? Because when you take the inverse, what do? There you go. Okay, determine the inverse function. Determine the slope when on the inverse function when x is 2. So you might not like this, but whatever. Okay. Do we agree that the inverse function can be written like this? So all I did was switch x and y. Okay, solve this for y. And then I sit back for a couple of minutes and laugh at you, because it's not possible to do very easily or nicely. Take the implicit derivative. So we're going to, because what we would like to do is switch x and y and solve for y, and then take the derivative and then substitute 2 in for x. Mr. App, that is too much work. So what we're going to do is we're going to instead, we're going to just take the derivative of this right now implicitly. So the derivative of the left-hand side is 1. The derivative of the right-hand side is, the derivative of 2y is 2y prime. The derivative of 1 is 0. Okay. Does this kind of look familiar? Practice this on the previous page. Yep. Factor of y prime. Prime bracket for 2. Y prime equals 1 over 5y to the 4 plus 2. Now, this is where I kind of got a little bit confuzzled this morning, because I was like, which set of coordinates am I using? Yeah, I am using, because this is all about the inverse. This is a whole inverse kind of process, even though I'm taking the derivative. So what I need to do is use the inverse set of coordinates. So what? It's just the reciprocal. Not the negative reciprocal. They're not perpendicular to each other. That's where my brain was this morning too. It's like, oh yeah, right, they're perpendicular. No, they're not. Not perpendicular. They're just reciprocal slopes. Yep. Do you want me to do? I don't want to prove it either. It's nasty. That formula. Mr. App, take the derivative of the inverse function. I need to know is the derivative of the original function and reciprocate it. So it's just 1 over. Cool, huh? Because it's about the inverse function, you have to use the inverse coordinates. But you don't need to. Like, look at what I've just said. Like, you don't have to go through process. All you need to do is, do we have a little? Like, I gave you, for example, the long winded process? Why? One cubed plus 1 squared plus 1. Okay, make a connection between what this question is asking you to do. What's f inverse 3? No, not the derivative, dude. The inverse, switch x and y. Inverse is just switching x and y. So what I'm saying is this. Yeah. So the graph, I like picture. It helps to make yeah? Oh, take the derivative prime of x. Three times 1 is 2 times 1 is 5. So the slope right here is 5. The slope right 1/5, and no work required. For the exact same point, well, there was the inverse point on the derivative graph. F prime of 3, yeah, good. F prime of 3. F prime of 3 is a better thing. F inverse prime 3 is cool. That was I didn't know that until I taught this course. This is something new for me. I never was taught derivatives of inverses like this. I actually had to do all that work on the up above. I just thought it was kind of cool. It was something new for me. Well, I do, but I don't. It's not something that I learned in my calculus career. I learned it when I did it with students for the first time. I was like, that is cool. So it was new. I'm always learning new things. So. No, it's 1 over. Yeah. 1 over that number up over there. It's just 1 over the.
I think it's the chance to rise, but
Yeah, you don't.
1 over f prime of 3 is not 1 over f prime of 3.
No, it's 1 over f prime of 1. I know what you mean. Okay, so at the bottom of on the page, your textbook. Looking for. So if I have a function, and then we're going to stop. You know what? Just put it on a blank page. And I want slope right there, and we'll call it a on curve is the derivative of evaluated at x. And if I take another and it's got it at f of a the slope is going to be oh yeah. Writing this right. I get this wrong. I don't want to screw it up. Yeah. Does that, you like that better? More complicated. All I'm saying is if this point has the slope of f of a, this point over here is going to have the slope of 1/7. F of a comma a. It's because when you do the derivative implicitly, you're going to end up with all these y's everywhere, and you're substituting in for y, which happens to be the y coordinate on the, but it's also the x coordinate on the original. You know what I mean? That's that whole relation coming in. Okay, or is that like one of those moments? I'm getting one of these looks. Is it not? It's all right, just leave it alone, Mr. At. You'll ask me later? Okay, so I'm done. That's it. We'll finish 2-8 tomorrow morning, and we get, or 2-9, whatever. 3-8 tomorrow morning, we'll finish that off, and we have 3-9 left to do, and we're done the chapter. Students who are rereading their chapter